Okay, so today we're going to start learning about electrons and atoms. We're going back to chapter 5. A couple of things I want to point out about what we have already learned. We learned back in chapter 4 that Democritus first proposed the idea of an atom. From there, we talked about John Dalton, and John Dalton is the one that told us about the atomic theory. As the years went on, J.J. Thomson discovered the electron, and then remember Rutherford, we learned he did the gold foil experiment, and he discovered the nucleus of the atom. And from there, Niels Bohr came along, and after that, Erwin Schrödinger. And we're going to talk about Niels Bohr a little bit today, and also Erwin Schrödinger in this unit. But these scientists paved the way for a better understanding of atomic theory. So in our classroom, we have atomic models. I have some projects that were done in the past that are representing the atom, where the protons and the neutrons are in the nucleus, and the electrons are orbiting around the nucleus in the electron cloud. These models are helpful to us because it gives us a visual of something that ordinarily we obviously couldn't see. So we're going to start off in chapter 5 talking about the value of atomic models and what we know about atomic models. We learned that after Rutherford did the gold foil experiment, we learned that the nucleus is where the positive particles are located. So we know atoms have a positive nucleus. We also learned that the atom has the electron cloud around the nucleus or outside the nucleus. And the electron cloud contains only electrons. So we know that the electron cloud itself is negatively charged. So this was sort of conflicting information among physicists back in the day when Rutherford proposed that the protons were in the nucleus and the electrons were surrounding it in the electron cloud. Because the question that a lot of physicists were coming up with was, this doesn't make any sense. If you have a positive nucleus surrounded by a negatively charged electron cloud, then why don't the electrons get sucked into the nucleus and fall into the nucleus? Well, Niels Bohr was the scientist that gave us an explanation of that. Niels Bohr explained that electrons in a particular pathway have a fixed amount of energy, and that is what prevents them from falling into the nucleus. Bohr gave us the idea of energy levels. So in the classroom, when you see the atomic models that some of my former students have made for their projects, you notice that they represented the atomic model, the model of the atom, with the Bohr model, is what we commonly call it. Now, we did get some valuable information from Bohr, but we no longer totally go with the Bohr model. We go with the quantum mechanical model, which is a totally mathematical model of the atom. But Bohr gave us some very important information and useful information as far as models go for us to understand the concept. When we think of an energy level, we're talking about the region around the nucleus where the electrons are most likely to be found moving. And yes, electrons are moving. They move around within the electron cloud. They're spinning and they're orbiting around the nucleus. They're not stationary. We know that electrons can move from energy level to energy level, as the notes say, from one energy level to another, by gaining or losing just the right amount of energy. This energy can be described as a quantum of energy. This is where we get our modern theory of the atom. The name of it is the quantum mechanical model. But basically what it means is that the energies of the electrons can be given a numerical value that can be quantized. Notice you see the root word quantity there, but they're given a numerical value. So let's talk a little bit about the quantum mechanical model, which is what we're going to focus on in this next unit. This model came from the mathematical solution to the Schrodinger equation. This is our only model of the atom that is purely mathematical. It's also the one that has been around for the longest. Basically, it assigns numerical values to the position of the electron within each energy level. So what's different about this model is it's not a physical model, it's a mathematical model. And another thing that's different is it does not define the exact path of an electron around the nucleus. Instead, what this model does is it estimates the probability of finding an electron in a particular position within the electron cloud. So it's kind of like its position in space will be like where its location is or where its home is. Just like we move around from day to day, from place to place, we have our home, but then we leave home and we go to school, or we go to ball practice, or we might go to a job, we might go shopping, and eventually we'll come back home. So as I talk about the location of the electrons within your electron cloud, keep in mind that just like we're able to move around, the electrons can move around too. We are going to be determining within this chapter the location of the electron. So I'm going to call that its address. So when I talk about the electron's address, we're talking about where the electron is most likely to be found 90% of the time. That's that probability that I was mentioning. The quantum mechanical model predicts that the electron cloud is where the electron is 90% of the time. So I'm sure that if you would relate where you are 90% of the time, you would not be at home 90% of the time. But when we find our quantum numbers today, what we're finding is the physical address of the electron, where it is found 90% of the time. Modern physicists believe that the electrons are found within these orbitals that we're going to be talking about. They're called atomic orbitals. And they also believe that it is impossible to pinpoint the exact location of the electron 100% of the time. But they do believe that with 90% accuracy, we can predict where the electron is found. Another thing I want you to understand is the electron cloud model, which is the quantum mechanical model. It views the electron cloud as a cloud-like region. That's where it gets the name electron cloud. Notice how this picture that I have on the slide shows the electron cloud. It's darker, more dense towards the nucleus, and as you move away from the nucleus, it gets lighter and lighter in color. And what the textbook does a really neat little job of describing it, it's kind of like a fan blade spinning. If you look at the propeller blades here on the picture you see, that would be sort of like what looking at the cross-section of the electron cloud would look like. The atomic orbitals are the cloud shapes. When I say electron cloud, there's actually 4 different cloud shapes that we're going to be learning about. The cloud shapes are the areas around the nucleus where the electrons are most likely to be found. And we call these cloud shapes the atomic orbitals. These shapes